I'm very excited to be here. My name is Aditya Challa. Thank you so much for your time today. Thank you so much for coming over. And thank you so much for people who are watching us live on the live stream as well. So my name is Aditya Challa. As I said, I'm a technical account manager with AWS Enterprise Support.
And I'm Prajakta Damle. I'm the product manager for AWS Glue and Lake Formation, which is a new service that's in preview right now for data lakes.
Awesome. Thank you. So today we are going to talk about building your data lake on AWS. So let's start with some positioning here. There is more data than people think. As we all know, data sets are getting bigger, and they're all coming from various different sources, diverse sources, like applications like CRM, ERP, and many other different applications. And they're all going into their own silos, right? And the velocity at which this data is coming in is also growing really fast, with machine-generated data and logs growing faster than business data, thanks to things like network-connected devices or microservices architectures, or just the growing popularity of DevOps. When we build a data platform, we need to keep in mind that data platforms need to survive a long period of time, like typically around 15 years. And so when we build something, a data platform, we need to think about not only today's needs, but also the needs that are going to fulfill this for the next 15 years. So with assumption that, well, we know that data grows 10 times typically in 5 years, we need to build something that, that can scale 1,000 times in 15 years. And there are more people accessing this data and more requirements for making this data available. So many teams within organizations, they would like access to this data, whether it's to run their business reports, or to run their ad hoc analytics, or to run their machine learning models. They would like the flexibility to self-onboard this data, run real-time analytics, or run massive scale queries and search this data, at the same time adhering to all the security and compliance requirements. So you might wonder, how do I democratize this data access to enable all the informed decisions that sub-organizations within my organization need to do, but at the same time employ governance and control so that there's no mismanagement or misuse of data? The solution here is a data lake, and many of our customers are moving to this data lake architecture. Data lake is an architectural approach where many types of data are managed in one place, and the data can come from different sources, and the data can be semi-structured, structured, unstructured, and they're all managed with a unified set of tools, and this data is readily available to be categorized or processed or analyzed or consumed by different teams and organizations. And the data that comes in is written as is in the data lake. So you don't have to think about what's the predefined schema going to be like, or think about what questions do I need to ask about the data that's coming in beforehand, of course. So let's take a look at what are the concepts of a data lake. How is it different from a data warehouse? And what are the value? What value is it going to bring in? So first of all, it's all data in one place, a single place of a single source of truth, so that teams within the company, they know exactly where to go when they need the data they're looking for. It handles structured, semi-structured, unstructured, and raw data. So just structured data is like CSV files or Parquet files. Semi-structured data is like JSON files or XML files. Unstructured or raw data is text files or log files coming in. Yep. So, and then it supports fast ingestion. Like I said, data is coming at very fast pace, and it's only growing. So we need something that can take care of, or that can handle that kind of velocity. At the same time, applications need to be able to read and consume this data really fast. So data lake needs to support that. And like I said, we don't think about schema at the time of writing. We let the data come in and write it as is. But at the time of reading is when we decide what schema or what kind of structure our data is going to be read in. It has to be designed for low-cost storage, and this is something very important, decoupling storage and compute. So back in the day, as we needed more and more storage, we also had to scale our compute resources. And so as we had more and more data coming in, our compute resources would also go up, and they would sit idle because they're not really processing the data. And so there would be unnecessary resources sitting idle, right? So if we decouple storage and compute, you can add data and ingest data as much as it's coming, as fast as it's coming in. At the same time, you don't need to scale your compute resources. You only need to scale your compute resources up when it's time to process the data or analyze the data. And once that's done, you can scale down, and you don't have to pay for those compute resources. And of course, this is very important. It has to support any kind of protection and security rules. Data lakes help you cost-effectively scale. So the first and foremost part of a data lake is to be able to handle exabytes of data. Like I said, we need to think about how can we scale for the next 15 years, like 1,000 times. So we need to be ready to take that kind of data, and S3 in Amazon is a perfect place because it's already capable of storing that amount of data. Another thing that I should mention here is typically data lakes have 3 stages when we store data. So the first stage is landing dock or landing zone, or some people call it bronze zone or swamp, where the data that's coming in is written as it is, raw data, without making any modifications. And the second stage is called the silver zone, or some people call it the pond, or refinery, where data it's basically staging data. So you're taking the raw data and making some modifications, doing some experimentation, doing some exploratory analysis, and storing it in that second stage. And finally, there is the catalog, or it's called, some people call it the lagoon or the gold zone, where data is refined and it's cataloged and it's ready to be consumed by any other teams that need to consume it. But at the same time, a data lake can, if there are people or if there are teams within your organizations who are interested in raw data directly without any modifications, they should be able to access that raw data as well. And data lake can make that possible. At the same time, if teams are trying to access the data from the second stage, the silver zone or the pond, they should be able to do that as well. So when we build our data lake, we need to make sure, or data lakes allow applications to consume this data from any stage as required. And this process of loading, transforming, and cataloging, you only do it once. And this is a perfect reason why it scales so well, because regardless of how many applications are writing to the data lake, and regardless of how many applications are reading from the data lake, you only do this once. You load it once, you transform it once, and you catalog it once. And so you don't have to move the data once it's there. And because of that, it's cost effective because you only are keeping one copy of whatever data it is. And in the beginning, when you first get started, you are only paying for the storage that you're using. But over periods of time, as more and more data is coming in, you pay for whatever that scale is. So making data available to any kind of tools within the organization. So there are some examples on the top, like Redshift or QuickShift or EMR or Athena. And then when we store this data, we make sure that we use open formats or interfaces. That way, teams can innovate and do more engineering on that data. So let's take a look at some of the architecture principles here. Building decoupled systems. This is very common these days. So for example, if we have data coming in, we store that data, we process that data, and then store it again and analyze, and then finally get some answers. If we put all that in the same machine or same place, scaling, you scale everything together. Maybe the first store process needs more scale than the second store process. So if you decouple them and make sure that one process or one component is unaware of the other component and let them just communicate with each other, it's a better design. That way you can scale all of them independently. The second thing, here at AWS, we believe that it's very important that we use the right tool for the right job. So for example, if I have to tighten a screw, the best tool for that is a simple screwdriver. I can get a very expensive Swiss Army knife that can do the job for me, but the right tool is a screwdriver, so I'd rather use a screwdriver. So looking at our data structure, our latency or throughput or access patterns for what we are trying to do, using the right tool for that particular job is a very important architectural principle. Leveraging managed and serverless resources or services wherever available. So this goes to any managed service. You can build these resources yourself, manage these yourself, maintain these yourselves, but you're spending a lot of time and resources on things that you don't really have to do. Somebody else can do that for you. So if you let AWS take care of that overhead, you can focus on your application at hand. Next, event journal design patterns. So a data lake, like I said, once you store the data, once you transform the data, and once you catalog the data, you should not, the principle is we should not touch that data. Let that data be immutable. So if an application requires data in a different format or maybe requires data from various different areas of the data lake, and it requires it in a particular structure, it's better to use materialized views that update themselves frequently, right? So, but your main data or the data that you originally loaded or transformed doesn't get modified and it stays there. Cost consciousness, just because it's big data doesn't have to be big costs. And just like everything else today, whatever we build, we need to make sure that it's ML enabled so that any future ML models can consume that data. So here are some typical steps. The first thing is storage. Customers need to think about where they're going to store this data lake. So they have to set up storage. If you're using AWS, you would do that with buckets and partitions, start with buckets and partitions. If you're doing it on-prem, you would start with a large disk of arrays where that data lake is going to be hosted. Secondly, moving the data into the data lake. So for this, we have to interface with whatever source data, whether it's in on-prem or a cloud platform or IoT devices, no matter where it is. We get that data in raw format, and then immediately we need to identify what kind of data that is so that you can organize it and send it to the right place within the data lake. And then immediately we need to crawl that data to understand what is the schema like so that we can add some metadata to it. That way, the next process that looks at that data has easy understandability of what this data is, right? So the third step is to clean this raw data and prep it. So like I talked about stages, you have the middle stage where you're transforming and experimenting. So this second stage, or the silver zone, is where you can take the raw data, make some modifications, and do some exploratory analysis. And at the same time, if you're ready to move it to the final stage, you can take that data again and move it to the final stage and catalog it there. So that's what the third step is. And this involves a lot of complex SQL queries usually, because the final place where you store that data is usually in the format of tables, so that you can query that data real easy. The fourth step is to configure and enforce security and compliance policies, so that any kind of data sensitive information that is on a need-to-know basis. So for example, you can enforce security maybe at the table level, or the row level, or at the column level, or encrypt this data and then audit who's accessing this data, right? So any PII information, any kind of sensitive information. Finally, it's very important to make this data available for consumption, right? So when we catalog this data, it's very important that we label this data properly so that teams who are trying to read this data can easily trust this data and know for sure that this is the single source of truth and this is the best place I can go to get this data, rather than figuring out, again, going back to the raw data and figuring out if the cataloging was done properly, right? So let's take a look at, yeah, sorry.
Is it right time to ask question or we can hold on?
You can go ahead.
So can you go back to your how do you ensure GDPR compliances to this data lake when this data lake may be containing data from different regions?
Data lake can contain different regions.
GDPR is for EMEA region.
Yeah.
It enforces some kind of like a compliance policy. And if it is a big lake, and data is coming across the globe, how will you make sure that GDPR compliance is?
So the question is about if we are creating this data, like say for example here in the United States, and the data is coming from different regions in the globe, and let's say some of the data needs to have GDPR compliances applied. How do we solve that? Do you have any?
So typically, GDPR compliance would require you to remove certain rows of data once the customer asks you to remove it. Is that what you mean by GDPR compliance?
User wants full control of their data, how it is right to be forgotten kind of thing.
Right. So right to be forgotten typically would mean that you need to delete the rows that have PII data pertaining to the customer.
Complication is like now, some of the information is going to the audit log also.
Yes.
How that kind of complexity will be managed in this data lake?
So typically, we see customers running jobs that run in the background and remove that data. And they would basically remove the rows. And that requires a level of sort of you need to read the data. You need to figure out what rows map to the users and then read.
In a typical small world, it's very easy.
Sure.
When we are talking about data lake, you can remove something from your bronze level. Raw data you can remove. But from bronze to it is going to silver and gold.
Right. Yeah.
There has been cleansing, processing, and everything got involved now.
Yes.
That data is into multiple places
Yes.
within that data lake.
Yep.
Now, how do you ensure that things are getting removed properly if somebody is asking right to be forgotten?
So typically, you would have some level of lineage component that will track, where all the data is flowing, and you can also put some of this into the metadata in the catalog to know where are your. I mean, the thing is that you still need to detect what fields for your organization map to PII or user information. It's not even PII, right? And then you would need to track that. There are products that track lineage for you that you can use to know where all the data has been written. And then you could essentially run a job to remove that data from. So it's a combination of tracking the lineage of your data and then running a job to cleanse that once a customer requests you to forget or ask you to remove their data.
Maybe we will discuss later on.
Sure.
Sure.
We can definitely discuss it during labs. Thank you. Yep. One more question. Yep.
Yeah, in relation to that, so the removal concept will not work if in step 5 we have third parties accessing the data. They have actually taken the data out.
So the second question is, with step 5, it wouldn't work if there's a third party trying to access this data that they shouldn't be accessing.
So
They can be accessing data for a right reason, but all of a sudden somebody say like I just want my data to be deleted.
So basically, how do you propagate, the forget
Yeah,
signal
right to be
downstream to the third party?
So from upstream to downstream. Now you can see there are many levels this data is getting stored, processed, and utilized. So it's not a simple database where you go and say like, okay, I know exactly this user is looking for all associated information to delete it.
Sure. So definitely we'll discuss that during the lab. But the question is about what if somebody wants to delete their data and somebody wants us to delete their data from their data lake? How would that get propagated across all 3 stages? So we can definitely take that offline. Yep.
Can you kindly go back 2 slides which was on materialized view?
Material. Yep. Yep.
So on bullet point, sub-bullet point 4, can you speak to the performance repercussions of using materialized views with immutable
So the question.
I want to add one more thing, because when you say immutable, transaction data is changes, so you cannot apply change.
Yeah, we
Data, and then you have to apply appropriate, filters, and then you have to aggregate. So all these things on a large scale data lake, what's the implication exactly? What you
okay.
Hey, sorry, I know it's, there are a lot of good questions coming out and these good discussions. Because you're doing the Twitch stream, we're kind of on a tight schedule, and it's harder for people following on Twitch to follow. But they're great questions, and I think we can help with that. So come chat to us afterwards, and we can dig much deeper into these.
Sure. Thank you. All right, so let's dive into some of the components. So the first component, obviously, is the base where we are going to store this data. So in this case, Amazon S3 is a perfect place. It's secure, it's highly scalable and durable. Object storage with millisecond latency. You can store any type of data like websites or mobile apps or corporate applications or IoT sensors, data coming from sensors at any scale. And the data that's stored can be unstructured, like I said, logs or any kind of dump files, or semi-structured like JSON or XML files, or structured files like CSV or Parquet. And you can also apply lifecycle policies on this data, right? So data that's new can be in standard tier. Data that's a few months old, that's not really frequently accessed, you can change it to a different tier. And finally, data that is ready to be archived, you can move that to Glacier. And you can set these policies up so that this change of tiers happens automatically behind the scenes so that you don't have to do that for every piece of data. And it supports, another great thing about S3 is that it's natively supported by major big data platforms like Spark, Hive, Presto, and others. Again, like I said, decoupling storage and compute. When we get new data, you get to add that to S3. You don't have to scale your compute clusters. When it's time to process this data, you can get EMR clusters on Spot instances. And once your processing is done, you can take those down. And another thing, data is in one place. Different applications, different heterogeneous analysis clusters, they all can read from the same place and the same data. And the other thing is S3 offers 11 nines durability, and you don't need to pay for replication within the region. AWS will take care of it, and it's secure. And the data that you're storing can be encrypted either with client-side or server-side encryption at rest, and it's low cost. So let's take a look at some of the ways to move this data into the data lake. So if you're moving data from your on-prem, then we have Direct Connect, which is a dedicated network connection. Then we have Snowball, which is a secure appliance to move data. I think it takes about 80 terabytes. And then Snowmobile, so if you have a lot more data than 80 terabytes, then Snowmobile can support up to 100 petabytes. And then if you have local databases on your on-prem, you can, to move that data into your data lake, you can use services like Database Migration Service from AWS. And if you have applications running on your on-prem, but you want to write to the data lake on AWS, you can use AWS Storage Gateway. And then if you have real-time sources like IoTs, you can use services like AWS IoT Core, which connect to the data lake on AWS. And then you can also use services like Kinesis Data Firehouse, Data Stream, and video streams to write real-time streams into your data lake. Now, before I go to the next slide, let me remind you that we talked about these three stages, right? We talked about the landing dock, the transform stage, and the catalog. So there has to be something, like I talked about, there has to be something that queries each of these stages and transforms the data that you need to write to the next stage. And obviously, if you do it yourself, it's pretty complex. And so it would be nice to have a service that can do that for you. And that glue between these stages is, again, AWS Glue. It's a serverless data catalog and ETL service. So first of all, you can crawl through the data that's coming in, but regardless of what stage it's in, and you can quickly catalog this data. And it lets you discover the data and create or detect schemas and make the data searchable and available for ETL. And then Glue can also author ETL jobs, so it can generate customizable code in either Python or Scala, and it can schedule these ETL jobs and run them, and it's completely serverless and flexible and built on open standards. So I talked about these crawlers. So these crawlers basically can automatically build your catalog and keep it in sync. So they automatically discover new data and extract schema definitions. And so they can detect any changes, any kind of new data. If it has a different schema, they can detect that and then version these tables. And then I think later in the afternoon, we'll talk about detecting Hive-style partitions in S3 with Gareth. And then they have built-in classifiers that come with popular types, or you can write custom classifiers with Grok expressions. And you can run these ad hoc or on a schedule, and they're serverless, so you pay only when they run. All right, so let's take a look at how Glue would help us with the data lake, right? So the data coming in is in raw format on this left bucket. Hopefully, on the left, and that's the raw data. And you have these crawlers looking at that raw data and then creating the catalog on the top. And then we also have ETL jobs created by Glue that can transform this data into the staging area, which again have crawlers on top that again catalog the data. And then finally, again, ETL jobs created to move or catalog the data into the final stage. And then again, we have crawlers on top that can make these catalogs, that can catalog that data. And this catalog is a single view of your entire data lake. And like we talked about, they discover any kind of schemas or new changes or new schema of new data coming in, and they make this data searchable. And Glue essentially is a serverless Apache Spark environment, and you can use ETL libraries or bring your own code and write your own code in Python or Scala, and even call any AWS APIs using the Boto3 SDK. So putting it all together, you have data coming in on the left, whether it's from Direct Connect or Snowball or Kinesis or IoTs or data migration service or storage gateway. And they're all going into that first bucket in the left, which is the bronze zone or the loading dock. And then you have these crawlers, again, and ETL jobs that are either cataloging or moving the data to the next stage. And once your catalog is completely ready with the data, you can use applications like Athena or Redshift or EMR to look at that catalog and further analyze that data. And you can use tools like QuickSight to visualize data that's inside Athena or Redshift. Or you can run machine learning models using SageMaker on the data that's processed by EMR. Question, yeah?
Does Glue only work on S3? Can you use EBS or other types of storage?
Yeah. Yeah. So the question was if Glue works only on S3. No, it can also look at EBS and other types of data, other types of sources. So the question is if Glue replaces Macie or extends Macie.
It doesn't replace or extend Macie. It could be used in conjunction with something like Macie. So Macie, for those of you who don't know, uses machine learning to identify things like personally identifiable information in your files on S3. So that could be, do you have files with credit card numbers, or do you have files with social security numbers? And so the purpose of Macie is to identify those kinds of personally identifiable information, where Glue is really about identifying the structure and the format of a file. So you'd probably want to use them together.
Right, let's talk about security real quick. So Amazon S3, the buckets and objects are private by default, and you can secure the data access with a combination of resource-based policies and bucket policies and IAM user policies. And you can also use KMS with client-side or server-side encryption for the data that you're writing to the buckets. And you can also use object tagging. So for example, if some of the data is personal health information, you can tag that so that in conjunction with IAM, you can make sure that access to that data is restricted and audited properly. And Glue is also, the metadata that Glue creates in the catalog is also secure. You can restrict it with IAM policies, and it's all managed by IAM, of course. And you can attach IAM principles like users or roles, and only those roles or users can read it. And you can also have resource-based policies which are managed by Glue. And you can have one policy per account or catalog, and similar to bucket policies in S3. And you can also allow cross-account access. So at this point, let me talk about, so far we talked about how to build this serverless data lake on AWS with S3 and Glue, but building can still take months. So here are some of the sample steps. So the first, we have to find the sources. So whether it's RDS instances or any kind of other data sources, we have to find those sources. Then we have to create these S3 locations where your stages are going to be, your data lake is going to be. Then we have to configure those access policies, and then map tables to the S3 locations. And ETL jobs, you have to create those to load and clean the data. We talked about those. Even if Glue does it, you still have to sometimes look at what it's doing, and also write Python and Scala data when necessary, Scala code when necessary. And creating metadata access policies, just like for your actual data, you also need these policies for metadata. And then you have to configure access for the services, analytics services that are trying to read from this data lake. So, and then you have to rinse and repeat this for all data sets that you have, all the users that you have, and all the end services that you have, and many more things that you have to do. And so I would like to let Prajakta talk about a service that we have, lake formation. Of course, it's a manual process, so we have a service that can help you, and it's lake formation, and I'll let Prajakta take over from here.
All right, thanks, Aditya.
Thank you.
So I think what Aditya kind of walked you through is just one example, which typically you do if you just want to query some data. He just walked you through an example, but as you get more data sets that you want to bring into your data lake and more use cases and teams that you want to onboard, this process could just get more and more complicated. So if you remember the diagram that he showed you, amongst the 5 steps, we typically see customers spending a lot of time in step 3, where they're prepping their data and cataloging it, and step 4, where they're making sure that the right access policies are in place. Sorry, my voice has seen better days, but hopefully you can still hear me. So with lake formation, we are really targeting three value propositions that will help you build your data lakes faster. We're making it easy for you to bring data into your data lake so that it's readily available for you to start querying that data. We are adding a new way to define security permissions for your data lake access so that the permissions could be defined once and enforced across multiple different AWS services. And then we are enhancing the Glue data catalog so that it's easier for you to search and discover your data and gain newer insights from your data. The service is in preview right now. This is some of the early customer interest that we've seen. This is 2 codes from Change Healthcare, which manages a lot of the healthcare payment and clinical information data, and then Fender Digital that builds digital experiences around Fender, the music guitar brand. And we have a lot of customers who have signed up for our preview. So if you want to try it out in preview, please go to our web pages and sign up. And we'll get in touch with you once we have whitelisted your account. So what does Lake Formation do, or what does it provide? It provides you a way to quickly bring in your data without really worrying about a lot of complex ETL, which you can still do with your existing tools. You can run it in Glue or EMR or any other tool that you might be using. And then it registers it with the Glue Data Catalog. So the Glue Data Catalog still remains your catalog, still remains sort of your central source of truth. Lake Formation provides you a way to apply security permissions around the catalog. So instead of thinking of applying bucket policies, IAM permissions in different services to access that data, and then also figuring out metadata permissions, Lake Formation allows you to do that at the table level. It provides you a way to, are we still taking questions? Do we have time to take questions, or maybe at the end, if that's OK? Cool. So the question is, so the question is, how do you access the Glue Data Catalog information? OK. Sure. So Glue Data Catalog is a managed service. It has APIs like any other AWS service. It does provide you a way to crawl information automatically from S3. We also support a set of databases, DynamoDB, where we can go and crawl the information and automatically catalog it. But you can use the APIs to put metadata for any data source and store it in the Glue Data Catalog. So nothing's stopping you from that. It's a managed service, just like any other service, AWS service. So the way you would interact with it is through our RESTful APIs. It can crawl on-premise databases over JDBC connection, the databases that we support, and I can go over that. So just to cover the four things that, the four different buckets of things that we're building capabilities in. So the catalog will provide search and collaboration capabilities, and then we'll also provide a way for you to audit all access, including data access, that goes through Lake Formation. So Lake Formation really builds on the capabilities that are already available in Glue, and we'll go through each one of these and what they do and what they mean. But essentially, Lake Formation will provision resources, Glue resources in your account. So you would have full visibility into what it is doing, how it is kind of processing your data, ingesting your data, and how it's managing your data. Your data still remains in S3. So for Lake Formation specifically, S3 is the storage layer that we are supporting. Your data remains in S3. You have, again, full access to your data. So we are not adding any proprietary sort of layer on top of it. If you already have data on S3, you can register that. You can register your buckets with Lake Formation, and Lake Formation can start managing access to that data. And you can take advantage of all the capabilities that Aditya went over, why S3 is a great storage layer for data lakes. You can still continue to leverage those capabilities without really getting locked into a particular service or technology. So let's look at what blueprints do. So blueprints are essentially recipes or templates that we're building that will allow you to easily bring your data into your data lake. And in the first set, these are the sort of sources we'll support. So we are going to support a set of databases, RDS databases or databases that you're running on EC2, or databases that we can go connect to over a JDBC connection. We'll also support ingesting logs, such as CloudTrail, ELB logs, CloudFront logs, and then we'll also support bringing data that lands on S3 from Kinesis Firehose into your data lake. So what exactly do blueprints do? So with a blueprint, we will expose a set of parameters that you can provide us inputs to. And these typically would involve things like, where is your data? So what's the connection? How do we get to your data? What are the credentials there? Where do you want us to land the data in your data lake? And how frequently do you want us to move that data? And then Blueprints will, under the covers, crawl your data, detect the source schema, automatically convert it to a recommended target format, partition that data if you've provided us a partition key, and keep track of updates. So we can do incremental updates, or we can bring the entire data set over to your data lake and overwrite what's in your data lake every time. Blueprints essentially, under the covers, will create glue jobs and crawlers. So you can customize the blueprint parameters, or you can actually go to your jobs themselves and edit those and customize those. No, the source tables could be in MySQL database, for example. And we can detect the schema, bring in the data from MySQL. If you want us to do it incrementally or based on a key, we can pick up the incremental records. And when we store the data into S3, you can also give us partitioning keys that we can partition on. Yes, target will be S3. Sources could be multiple different sources. In addition to Blueprints, we are adding ML transforms. These transforms can be trained on the data that's in your data lake. So you can point us to a table in the catalog. We can generate a sample set that you can go and label. You can also bring in your own label set and provide it to these transforms. And then you can run these as part of a glue job, essentially. What do these transforms do? So here are a couple of examples. What they typically do is they use fuzzy matching logic to find out that two separate records are the same record. So this is beyond just matching a key. So if you have, say, movie listings coming from two different providers and you want to know this is the same movie, you can train the find matches transform that we are adding, and you can run it on your data set. Excuse me. Similarly, you can deduplicate a set of records. And this is an example where this is from the Amazon catalog, retail catalog, and you can know that these two products are the same, and you can deduplicate them if you like. So that's on the data ingest piece. Moving to the second bucket of things that Lake Formation is building functionality in, it's the security permissions that Lake Formation is adding. So this is just a view of the world today, especially with Glue and S3, where you are securing your data access separately from your metadata access, and that typically gives you table-level access. So with Lake Formation, we are actually allowing you to define your security permissions based on tables and columns instead of objects. And then Lake Formation will actually map that to the underlying objects and vend out access to the services that integrate with Lake Formation. So this is basically just walking you through a flow. As an admin, you can set up permissions. Excuse me. As an admin, you can set up permissions on tables in the data catalog. Your end users who are querying this data from a variety of AWS services do not need direct access to S3. They basically just need access to tables in Lake Formation. And then based on the permissions that are defined, Lake Formation will vend out temporary credentials to the service that's querying that data. Yeah, so the permissions will be one set of, so the question is, what about catalog permissions? So with this permissioning model, there's only one set of permissions. There's no separation between metadata permissions and data permissions. You basically would give access. So if you can see the screenshots here, you'd basically give access by saying grant a set of permissions, grant create permissions, select permissions, alter permissions, to a set of principals, which could be IAM principals, which is an IAM user role. We're also working on support for Active Directory users and groups, especially for EMR or use with EMR. So you would define these permissions through Lake Formation. And these permissions can allow you to scope down access not only to a table, but a subset of columns. So you can see here with this visual representation, user 1 has access to all the columns that don't have personally identifiable data, but user 2 has access to all the columns for this table, which is Amazon's review, Amazon reviews table. Yes. Yeah, so if you look at this security, so the question is, the restriction at the catalog level, is that propagated to the data? So when you register a bucket with Lake Formation then starts wending out access to data that's stored in that bucket. So the first step typically is to say that this is the boundary of my data lake. So not all your S3 buckets are your data lake buckets typically. So you can register that with Lake Formation. And then you can go and catalog the data. So you can either crawl it and catalog it, or you can run your own DDL statements and catalog that data. So the tables basically would have a location to where your data is. So the tables would map to that data. Once you define your security permission, so if I say grant select access to this user to a particular table, when this user runs a query, such as select star, through any of these services, and let's take an example of Athena, for example. So if you run select star in Athena, Athena will request Lake Formation for access. So Athena will say user A is trying to access table, run select star on table T. And then Lake Formation will verify the permissions and send temporary credentials back to Athena. Athena is still the one querying the data, so Lake Formation is not in the data path in any way. Essentially, Athena is the one that will query the data, filter out the required columns, and then return the results back to the user. The users are authorized by Lake Formation. They're still authenticated through our IAM service. So by authentication, I mean that IAM will tell us that the user A is actually user A. So that authentication happens through IAM. But the authorization will happen in Lake Formation. So moving to the search question. Let's take one question, because we're running really close to time.
I have a curiosity to understand that when we are talking about this data lake, we are talking about multiple sources with a disparate data type and structure.
Yes.
Ultimately, when you are creating and generating the catalog, it's a RDBMS kind of structure.
Yes.
Making queries.
Yeah.
The question here is, in a typical RDBMS world, you have a schema that you define with a table structure and another thing which is fixed. And unless you change it, everything will be structured, your query will be going to the schema definition and get it. Now, in this world where you are continuously getting the new data,
Yep.
different kind of data, varieties of data,
Yeah.
and you still need to catalog it,
Yeah.
how do you maintain the table structure?
Yep. So we have crawlers that can run on a schedule, and they can actually detect schema changes, automatically catalog the schema changes, and alert you that there is a schema change. So crawlers provide you that. You should think of the Glue Data Catalog as a replacement for the Hive Metastore, which already exists in the big data world. And if you have ETL process that already is updating the Hive Metastore, you can continue to use that. So as part of your ingest or as part of your ETL, you could update the catalog. Or if you want to basically decouple that, you can run glue crawlers to go and scan your data. So glue crawlers essentially sample your data. They don't actually read all the rows in the data. And then they'll detect things like, there's a new column that has appeared. Or if it's a JSON data set, new key value pairs that eventually would map to a column that have appeared in your data. And they can automatically catalog that.
So I have a follow-up question on it, because now your analytics and everything is dependent on certain structure,
Yeah.
catalog structure.
Yes.
Now, when they have written application to consume that data for
Yeah.
analytics purposes,
Yeah.
when they are sending the query,
Yeah.
query was supposed to be based on some of the structure that catalog had.
Yeah.
Now you have introduced new
Yeah.
columns and other things. How it will have impact to those downstream tooling and analytics things?
So it depends on what tools and how your queries are written. If you have queries that are querying a specific set of columns, so the question is, how do your analytic tools react to your data changing if you have new columns being added? So if your queries, say, are written, SQL queries are written such that they are querying a specific set of columns, they will run fine, because those columns, if there are new columns being added, they will still run. If there's select star, you'll get the new data. So it really depends on what your queries are. we don't see data being deleted as often in data lakes. It can happen. But if that happens and your query is asking for a specific set of columns, then unfortunately, that query is going to break or is going to get null values back.
So how will they get alert about schema changes?
So crawlers, both crawlers and Glue Catalog send table notifications to CloudWatch, and you can build a mechanism there to consume those table notifications if your downstream processes are very tightly coupled to the schema. You can also have crawlers set so that they don't automatically update, and they can only alert. So that is also possible. So crawlers have a set of configuration options that you can play with depending on how your downstream tools are expecting the data to be.
You have an option to customize
Yes.
rules,
Yes.
enforce rules.
Yes. Yes. Yep. Athena works directly against S3, and it works, there's an out-of-box integration with the Glue Catalog. Redshift Spectrum, if you have data in Redshift and you also have data in S3, you can use the Redshift cluster and Redshift Spectrum to query that data. Yeah, it depends on I think Athena is more for ad hoc querying. If you just want to do ad hoc querying and you want to go to interface and start running your SQL queries, then yes.
Unfortunately, we only got about 10 minutes left, so
I think I should have. I have only
end.
one more slide, so I should have time for questions.
Okay.
Let me just finish it,
and then
we'll take questions, or maybe 2 more slides, but I'll be quick. So we are enhancing the search capability in the catalog. So we're making it a text-based search as part of Lake Formation. So as I mentioned, the Glue catalog remains to be the same catalog in Lake Formation, but you get the ability to define security permissions around the tables that are in your catalog. We'll have a text-based search across all the metadata, including custom metadata that can be stored in the catalog. You are already able to add attributes like data owners or data stewards at the table level using table properties in Glue Data Catalog. We are also extending that to columns. So we will have a bag of key value pairs, a bag of properties that you can add at the column level. You can add more context to the columns. You can add things like sensitivity levels, et cetera, to your columns. And then you would be able to search on those fields and find the relevant data sets. And then typically with CloudTrail today, you can get audit logs for API access. But with Lake Formation, we will also provide you data access audit logs for all the data access that goes through Lake Formation. So with the logs, you can see things like what permissions were granted and revoked by which user, who accessed the data from which service, what was the requested query, what was the result that was returned. And you can download. Some of the recent alerts would be available through the console and through our APIs, but you can download all the audit logs from CloudTrail just as you do for other logs in AWS. I think that's all I have. This is just a quick overview slide of how our analytics portfolio stacks up for different use cases. And that's it. That's our contact information, and I'll take your question now. So Tableau can be connected through Athena or Redshift right now. All the, yes, not directly through Athena. So Athena provides a JDBC driver to Athena that you can use to connect Tableau, QuickSight, BI tools. You don't need a Redshift as far as I know, yeah. Yeah, we have 5 more minutes, so more questions.
First off, thanks for explaining all of this to us.
Sure. Sure.
Have a Parquet file sitting on S3, have 10 columns in this file. 5 of these columns should not be visible to some users.
Mm-hmm.
You want to use Lake Formation to set up that permissioning scheme.
Yeah.
You're using EMR to access those files.
Yeah.
How does that then work?
So the question is, there's a Parquet file. It has 10 columns. 5 of those columns need to be obfuscated in some way to a particular user. So the user should only be seeing the 5 columns. So with EMR, we are actually building integration so that an Active Directory user can log into an EMR cluster and query data using the Active Directory credentials. So you can have multiple Active Directory users logging into the same EMR cluster. They can be federated into an IAM role to get authenticated. But we can use SAML tokens, or we will use SAML tokens to differentiate between one user from the other. And in Lake Formation, just as the example showed an IAM principle, you can add an Active Directory user there, and you can say this user has select access to these set of columns, or has select access to all columns except these columns. So you have option to either exclude or include. And then EMR will come to Lake Formation, just as the Athena example, to request access and then use the temporary credentials that Lake Formation passes back to query data, filter the columns out, and return the results back to the user. Yeah. I don't know if we, so this is just with, like, your question is, do you have any comparison for performance across Redshift, Athena, and Redshift Spectrum?
Yeah, S3 now we can do directly to Athena, and or Redshift Spectrum.
Right.
Standalone.
Yeah.
So why do you go for one over the other, and then we do EMR, then let's transform. That's the main structure. So now you have so many options.
Yeah, I mean, I think. Okay, that's fair. I think the question is, how do you choose when to use EMR versus when to use Athena, when to use Redshift Spectrum? So part of it depends on your data. So if your data is largely, part of it depends on your data, and part of it depends on who is accessing it. So if your data is largely something that is sitting in Redshift, and you also are having data in S3, and you want to use Redshift essentially to go across Redshift and S3, or use the same cluster to query data in S3, then Spectrum provides you that capability. It can do things like mixed views and things like that. I mean, you can also use Spectrum for just querying S3, but Spectrum requires you to have a Redshift cluster. If your use case is, I have a lot of data in my data lake, and I want to, run some ad hoc analysis once in a while, or even, I mean, we see customers using Athena, where they are scheduling Athena queries as well. So if you want to just use Athena and use serverless Presto, Athena is based on Presto, then Athena is a great choice. We have customers who want to use EMR because they need the tight control over how do they provision the cluster, manage the cluster, what kind of instances they have for that cluster, and then fine-tune the cluster. They share it across multiple different use cases. And EMR gives you sort of a way to run Presto, Hive, Spark. So depending on what application you want to run and what kind of tools you want to use, you might want to use EMR for that. We have a lot of customers still using Hive. Yeah. Yeah. I mean, and then you also have Glue that provides you serverless Spark. So if you want to use, a serverless Spark platform for data processing or for SQL, Spark SQL-like queries, then you have some options there. So hopefully that. Yeah, I don't know if you have any published metrics, but that's good feedback. We'll take that back. Yes, so we'll have all APIs. So the functionality that you saw will be available through APIs, and you should be able to access it through our API. So the column level access is only available through the services that are integrated with Lake Formation, but we would be able to give you table level access through APIs and other functionality through APIs, like accessing the metadata or accessing permissions or setting permissions, all of that. Sorry, I couldn't get your question. So do you? Do we have ML tools that work with Lake Formation that have test environment? I'm not quite sure I understand your question. I don't know if you do, but
Actually, unfortunately, time's up, but come chat to us afterwards and we can dive into that a little bit more. Time's up, though, but that does mean it's time for labs. And followed by lunch. Thanks so much for that. Appreciate it.
Sure.